In 10.2, we're going to review how to find the area and circumference of circles. In addition, we're going to learn how to find the area of polygons. Remember, polygons are shapes with many sides. So first we have the circumference and area of a circle. We've already learned this in the past, so this part is just a review. So our two formulas here that we need to remember to find the circumference of a circle. So remember, the circumference would be as if we were walking around the outside of the circle and trying to find that length. This formula is pi times d. D stands for the diameter, which goes directly through the middle of the circle. Or our other formula we have for circumference is 2 pi r, and r stands for the radius, which is the part that goes from the middle of the circle to the end of the circle. So remember, the radius is half of the diameter. Next, we have the area of a circle. So our formula for area is pi r squared. So we take the radius, square it, and multiply it by pi. So area is trying to find everything on the inside of the circle. So let's do an example. Find the area of circle K in terms of pi. So we're finding the area, which we know our formula is going to be pi r squared. So here we need to find our radius. It gives us the diameter, which is the line that goes through the whole circle, but we need to find the radius, which is just half of this. So we just divide 6 by 2, so r is equal to 3. So our area is equal to pi times r squared, so 3 squared. 3 squared is 9, so our area is 9 pi. Our problem gives us the unit of inches, and remember, area is our unit squared, so we can just tack on an inches squared at the end. Next, we need to find the circumference. We know our formula for circumference is pi times d. Here it gives us the diameter, which is 6, so circumference is equal to 6 pi. Circumference is just the length if we were walking around the outside of the circle, so it's not squared, so it would just be inches. So our final answer for area is 9 pi inches squared, and our final answer for circumference is 6 pi inches. Next, we have to find the area of circle D in terms of pi. So here it gives us the radius. So our formula for area is pi r squared, and our formula for the circumference, even though it doesn't ask for circumference, I'm still just going to find it anyways, is 2 pi r. So remember, we have two formulas for circumference. It's either pi times d or 2 pi r. I'm using 2 pi r for this one since it gives us the radius here and not the diameter. So first, let's find the area. We have pi times 7 squared, which 7 squared is 49. So 49 pi, it gives us feet here, so feet squared. One way you can tell these formulas apart is you know that your units when finding the area always have to be feet squared or inches squared. It always has to have the squared. So our formula for area will always be radius squared, whereas the circumference doesn't have the r squared. It's 2 pi r. So that's the difference. So we have the circumference is equal to 2 pi, our radius is 7, So circumference is equal to 14 pi inches. So I just multiplied the 2 and the 7 together and got 14. Okay, our next example asks us to find the circumference of circle T in which the area is equal to 16 pi millimeters squared. So we know that our formula for circumference is 2 pi r. So in order to find the circumference, we need to know what our radius is. We need to know what this r is in order to solve this equation. So we need to take this formula that we have for area and try to find what r is. So our formula for area is pi r squared. It gives us that our area is 16 pi. So we're just going to plug this in for our a in our formula. So we have 16 pi is equal to pi r squared. We can divide pi, because our goal is to get r all by itself in order to find out what this r is. So we divide both sides by pi, so it cancels out on both sides. So we have 16 is equal to r squared. In order to get this r squared to become an r all by itself, we just need to take the square root of both sides. So we have 4, because the square root of 16 is 4, is equal to r. So now that we found our radius, we're just going to plug it in into this formula. So our circumference of circle T is going to be equal to 2 pi times 4. So our circumference is 8 pi. And then our units, it gives us millimeters squared for the area. But remember, circumference isn't squared, but it's the same unit. So our unit's just going to be millimeters. So this is our final answer. Now we're going to move on to try to find the area of polygons. So first we have the center of a regular polygon is equidistant from the vertices. The apothem is the distance from the center to a side. A central angle of a regular polygon has its vertex at the center and its sides pass through consecutive vertices. Each central angle measure of a regular n-gon is 360 divided by n, which we'll go over all of this on the next page. So the center of the polygon, which is this point right here, is equidistant to all the vertices. So this segment is going to be the same length as this segment, it's the same length as this segment, and this segment, and this segment. So this central point is the same distance to every single one of the vertices. So remember, the vertices is this point that's formed by the two sides. So we have vertex there, vertex there. So all of these are vertices. The next thing that we need to know about polygons is our apothem. So this segment from the center of the polygon to the side, and it forms a perpendicular angle. So this segment from the center of the circle to B is our apothem. So remember, the apothem is always going to be perpendicular to the side. So we could have another apothem here if this is perpendicular. So the apothem is perpendicular. And lastly, the paragraph on the last page talked about central angles. So this angle here is a central angle, this angle here is a central angle, this is a central angle, this is a central angle, and this is a central angle. So here we have a polygon with 5 sides, so it's a pentagon, and we have 5 central angles. So in order to find what the measure of just one central angle is, we take 360 divided by the number of sides, which is 5. So 360 divided by 5 is 72. So each one of these angles is 72 degrees. So each central angle is 72 degrees. And we found that by taking 360 divided by the number of sides. So next we have the area of a regular n-gon with side lengths s is 1/2 the product of the apothem A and the perimeter P. So to find the area of any n-gon, so any polygon, our formula is 1/2 the apothem times the perimeter. So A stands for apothem and P stands for perimeter. We can also write the area of a polygon by multiplying 1/2 times the apothem times the number of sides times the length of each side. So our two formulas here that we have for the area of a polygon are these two, and you can use either one. To find the perimeter, we can find that by just multiplying the number of sides times s. So that's why both of these formulas will work anytime. Okay, our example says find the perimeter and area of each figure. So a regular hexagon with the apothem 6. So our formula for area, because we have to find the perimeter and area, so our formula for area is 1/2 apothem times perimeter, and then our formula for perimeter is the number of sides times the side length. So always when we start off, we need to find the length of the apothem, the number of sides, and the side length. So it tells us that it's a hexagon, so we know our number of sides is going to be 6, and it tells us that our apothem is 6 as well. So next we have to find the side length. So we need to draw out this picture in order to find what our side lengths are. So here's our hexagon, and I'm going to draw a triangle with our apothem. So remember, our apothem is the perpendicular segment, and it tells us that our apothem is 6 here. Now we need to find out what this central angle is in order to find out what our side length is. So we need to find the side length, so this length here. So in order to do that, we need to do a little bit more math. So we need to find what the central angle is, and hopefully we can use one of our special right triangles and find the other side lengths. So in order to find this central angle, we would do 360 divided by our number of sides, which it's a hexagon, so it has 6 sides. So 360 divided by 6 is 60 degrees. So this whole thing here is 60, which that would make this part here 30 degrees, because we would need to cut it in half when just looking at this triangle. Let me make it a different color. So we're looking at this triangle, the green one, and this angle here is 30 degrees. If this is perpendicular, that means that's 90 degrees, and this one would have to be 60 degrees. So now we need to use our special right triangle tricks that we know in order to find this length to find the side of our hexagon. I'm going to redraw the triangle that we're looking at over here just so we can look at it a little bit bigger. So this angle down here is 60, this is 30, and this length is 6. So we know our special right triangle. If this is 60, this is 30, and this is 90, across from 30 is our x, across from 60 is our x square root 3, and across from 90 is our 2x. So here it gives us what's across from 60, and we know this is our x square root 3, so we're going to say 6 is equal to x square root 3, and now we need to divide by square root 3 on both sides in order to find what x is. So we have x is equal to 6 over square root 3. So x is talking about this side here. So 6 over square root 3 is this length. So it would be this length here, 6 over square root 3. Now that's just half of one side of the hexagon. So we need to find the other half, and we can just do that by multiplying this by 2. So we have 6 over square root 3 times 2, which we just multiply the top, and we get 12 divided by square root 3. In order to rationalize this, I'm going to multiply the top and bottom by square root 3. So this is just to get the square root from under the denominator, so we don't want it to be on the denominator anymore. We're going to multiply straight across, so the bottom becomes 3, and the top becomes 12 square root 3. And now we can just divide 12 by 3, so we get 4 square root 3. So all of this from here to here is just rationalizing it in order to get that square root from out of the denominator. So our length of our side is 4 square root 3. So our side length is 4 square root 3. So now we just need to plug all of these into our formulas. So in order to find the perimeter, we multiply the number of sides by the side length. So 6 times 4 square root 3. We just multiply the 6 and the 4 together. So our perimeter is 24 square root 3. Next, we need to find our area. So our area is 1/2 the apothem times the perimeter. So our area is 1/2. Our apothem is 6. And our perimeter is 24 square root 3. So we can just multiply the 1/2 by 6, and we get 3. And then we multiply the 3 by 24, which gives us 72. So multiply these two together, got 3. Then 3 times 24 is 72, and then we just tack on the square root 3 at the end. So our final answer here for our perimeter is 24 square root 3, and our area is 72 square root 3. Next, we need to find the area and perimeter of a regular octagon with side 5 and apothem 3. So we need to find our apothem, our number of sides, and our side length. So these are the 3 things that you always need to find when trying to find the area and perimeter of a regular polygon. So our apothem, it tells us it's 3. Our number of sides, it says that it's an octagon, and we know octagon has 8 sides, and our side length is 5. So here, everything's given to us, thank goodness. So we need our formula for the area of a polygon, so 1/2 a times p, and our formula for perimeter of a polygon. So we have perimeter is equal to number of sides times side length. So first, let's find our perimeter. The number of sides is 8, and our side length is 5. So we just take 8 times 5, and that gives us 40. And now we're going to need that to plug back in. So we have our area is equal to 1/2 our apothem, which is 3, times the perimeter, which is 40. So I'm just going to multiply 1/2 times 40, and we get 20, and then 20 times 3, which is 60. So our area is equal to 60. This one was a lot less work than the other one because it gave us our apothem, our number of sides, and our side lengths. But it's not always going to give us all 3, and sometimes we might have to do extra math to find this last one. So it's important here that you guys know your special right triangles and brush up on these 30, 60, 90 triangles and 45, 45, 90. I'm just going to write it on the side here just to remind you guys the 45, 45, 90. So this is 45, this is 45, and this is 90. Across from the 45 are just your x, and then across from 90 is your x square root 2. So these two triangles are very important that you guys have to remember for this section. Okay, last examples. So now we need to find an equilateral triangle with apothem 8. So we can draw our equilateral triangle. We have our center. So this is our apothem, and it's 8. So remember, we need to find our apothem, our number of sides, and our side length. So here it tells us our apothem's 8. Our number of sides, equilateral triangle, so triangle, 3 sides. And we have to find our side length. So we need to find what this length is. So we need to do some extra math here. So looking at this triangle, we can make another triangle there. We can find what this angle measure is by doing 360 divided by the number of sides, which is 3. 360 divided by 3 is 120. So this whole angle here is 120, which means that this part here is just 60. Do that in a different color, 60. So this angle is 60. So if that angle is 60, this one's 90, that means this one is 30. Remember in our 30, 60, 90, if across from 30 is x, across from 60 is x square root 3, and across from 90 is 2x. So here it gives us across from 30, which is 8. So x is equal to 8, so we know that across from 60 is going to be 8 times square root 3. Now, we just found this half of the side length, so in order to find the whole side length, we just need to multiply that times 2. So we have 16 square root 3 as our whole side length. So our side length here is 16 square root 3. Now we need our formula for the area of a polygon, which is 1/2 apothem times perimeter, and our formula for perimeter, which is number of sides times the side length. So let's find our perimeter first, because we need that for our other formula. So we have the perimeter is equal to 3 times 16 square root 3. So we just need to multiply the 3 and the 16 together, and we get 48 square root 3 for our perimeter. And now for our area, we just need to plug everything in. So we have 1/2, our apothem is 8. So 1/2 times 8 times 48 square root 3. So we can just multiply the 1/2 times 8 and we get 4. So 4 times 48 square root 3. 4 times 48 is 192. So our area is equal to 192 square root 3. So that's our area of our triangle, and that's our perimeter. Next, last one, we need to find the area and perimeter of a regular hexagon with side 12. So we need to find our apothem. Remember, the lowercase a stands for apothem, uppercase A, capital A stands for area. So we need to find our apothem, number of sides, and side lengths. So here it tells us our side length is 12, and it's a hexagon, so our number of sides is going to be 6. So now we have to find the apothem. So let's draw our hexagon on the side over here. So we need a shape with 6 sides. If we have a point in the middle, our line here is our apothem because it's perpendicular to the side. And then we have our central angle here. So we need to find the measure of our central angle. So we do 360 divided by 6, because this has 6 sides, which gives us 60 degrees. So this whole blue angle is 60 degrees, so we need to note that this half is just going to be 30 degrees. So we just cut that 60 degrees in half, so we have an angle that's 30 degrees. That would make this angle down here 60 degrees. Now it tells us that our side length is 12, so this whole length here is 12. So if we were just taking half of that, it would be 6. So just looking at this triangle, so I'm just redrawing this triangle here. 30, 60, 90, this side length is 12. We need to find this height here, which we know in our 30, 60, 90, across from 30 is x, and across from 60 is x times square root 3. So all we do is multiply 6 times square root 3. So our apothem here is going to be 6 square root 3. So now we found everything, so we're just going to plug that into our formula. So we have our area is 1/2 apothem times perimeter, and our perimeter is the number of sides times the side length. So let's find our perimeter first. We have our number of sides is 6, our side length is 12, 6 times 12 is 72. Now we just plug that into our area formula, so we have 1/2 our apothem, which is 6 square root 3, times our perimeter, which is 72. So we can just multiply the 1/2 by 6 square root 3, which gives us 3 square root 3 times 72. So our area is equal to 216 square root 3. So all I did was multiply the 3 and the 72 and just tack on the square root 3 at the end. So our final answer for area is 216 square root 3 and perimeter is 72. Alright, so this is everything you need to know for 10.2.